Hey everyone, today we are going to start topic 3, which is our transformations chapter. And we are specifically going to look at reflections today. Now, transformations are anytime you move or change either the shape of a figure, the orientation of a figure, the direction a figure is facing, or the location of a figure, that is a transformation. If we have transformations that do not change the size or the shape of the figure, those are called rigid motions or isometries. When we do a transformation, we start with an original figure and then we do something to it to get a new figure. The original figure is called your pre-image and the new figure is called your image. Okay, with reflections, we are going to, and in the past you have called it a flip, we're going to flip a figure over a line. That line is called the line of reflection. When we look at our line of reflection, so if we look at this image over here on our right side of our page, we can see that our line M here is our line of reflection. So point A, B, and C have all been reflected over the line in order to create a new triangle on the opposite side. What I want you to notice is that with this line of reflection here, it is going to cut the segment that is going to connect your pre-image point and your image point. It's going to cut it in half. So this is going to be the midpoint, and it's going to be perpendicular. So we see this right angle symbol right here. So every line of reflection is going to be the perpendicular bisector between each pre-image point with its image point. So from C to C prime here, line M will be the perpendicular bisector. Now, we do have some new notation that you may not have seen before, and that is this little guy right here, this prime symbol. When we are looking at prime notation, we can see that that tells us that that is the image. So I can see here that B is the original image and B prime is my post image. So B is the pre-image and B prime is the image. So I have moved B over to B prime. All right. So what we're going to look at in this next piece here is whether or not just the figures look like they have been reflected. So if I look here at part A, I've got, it almost looks like a C here, and it is backwards. So it looks like I have taken it and I have flipped it over a line kind of here. So yes, this is a reflection, or it does look like it's one, because it appears to be flipped. And you can say that yes, it looks flipped here, and that is fine. But just know that in things that it's not just, does this look like a reflection? We want to use proper vocabulary, and I want to say reflection, but this one I'm kind of just describing the reflection. So flipped is fine. When I look at part B, the orientation of this figure is the same. It has not flipped over anything. So this looks like it's just been slid over to the right. So we're going to say that this is no, it has been slid, or it is a slide. And that's a translation, which we will talk about here in another section or so. The next thing we want to look at is ways to notate our reflections. So if we look, we're going to have two different ways to notate a reflection. I'm going to have a coordinate notation and a transformation notation. Our coordinate notation is basically going to tell us what happens with each of the coordinates. So if you notice here, I start with XY, and then this is going to tell me what XY does. So when I look at that, if I look at a point, if I just pick 2, 3 as a point to kind of look at, if I'm reflecting over the x-axis, the x coordinate is going to stay the same, and I'm going to change the sign of my y coordinate. So if I take 2, 3 and I flip it over the x-axis and I reflect it, I'm going to get 2, -3. Okay? The other way we can look at this is in transformation notation. Reflections are going to be a lowercase r, which you can see right here. And then we're going to do a subscript. The subscript is going to tell us what line we're reflecting over. All right, so the subscript tells us what we're reflecting over, and it can be any line. It doesn't have to be the x-axis, the y-axis, or specific lines. The transformation notation works for any line. I could say I'm going to reflect over the line x = 1, and that's fine. And then what's in the parentheses tells you what you're reflecting. Then we're going to write an equal sign, and it's going to tell us what we got out of that. So if I reflect triangle ABC over the x-axis, that's going to give me A prime, B prime, C prime. We can also use this with coordinate notation. It kind of mixes them together. We see that little r, we're reflecting over the x-axis. If I reflect a point, it's going to give me the same x value and flip the sign of the y. All right, the same thing is going to be true with our y-axis, except instead of negating the y, we're going to negate the x. So if I still use that 0.23, this would be -2, 3. All right, and again, the same type of notation with our transformation notation. The subscript is the line you're reflecting over, then what goes in the parentheses is whatever you are reflecting. All right, the line y = x, in our graph is our diagonal line with a slope of 1. And what that's going to do is it's going to switch our x and our y coordinates. So if I use that same 0.23, then when I reflect over the line x = y, my coordinate becomes 3, 2. Okay, so one of the things that I want you to notice is coordinate notation, we only use it for these reflections. It is only x, y, and the y = x, because we have those specific rules. Everything else is going to kind of depend on what you're reflecting over. So if we're reflecting over any of the other lines, we're pretty much going to use that transformation notation. All right, if you have any questions on that, please write it down on your notes page. The question box for this one is on the back. All right, the next thing we're going to do is, it says draw the reflection of the quadrilateral across the line. When we're drawing, we're essentially just going to sketch. I'm not going to expect perfection here in any way, shape, or form. Okay, so what we're going to do, and you've got your steps over here on the left, is that we're going to try to make each point have each line be the line of the perpendicular bisector of each segment. So what that means is we're going to look at going from this point here, and I want to try to make it so that it draws about the same distance on the other side. I want this to be perpendicular, and I want these to be the same. So that's going to be close. Again, not expecting perfection here. Then we're going to do the same thing with this point. Try to get it to 90 degrees and try to go about the same distance on the other side. All right, do the same thing over here. Try to get it 90 degrees and go about the same distance on the other side. And repeat with our last point. Again, I am not expecting perfection on this. I want to be close. So that is how we do our reflection over a line. We are essentially sketching it. All right, if you have any questions about that, please write that down now. Okay, then the next thing that we're going to look at is actually performing a reflection using our information. So we want to reflect over the line y = x. So I'm going to take the point 2, 3, and I'm going to recognize that my line y = x, and I'm going to kind of go a little bigger here, is this line right here. That is your line y = x. So what we do is all I have to do is remember that for this particular reflection, I switch my X and my Y. So if I have 3, 2, I'm going to graph, or excuse me, if I have 2, 3, I'm going to graph 3, 2, which is right here. The other way you can kind of do this is to count diagonally to the line. I've got half a box here. I'm going to have half a box on the other side in the opposite direction. Okay, so my answer here is the coordinate 3, 2. And we do want to include the graph as part of that. All right, this one we're going to reflect the point 2, 3 over the line y equals 1. So y equals 1 means, or excuse me, negative 1 means that every y value on the line is negative 1. So 0, negative 1, 5, negative 1, negative 3, negative 1. All these is the line y equals negative 1 because all the y values on every point on that line is negative 1. So the easiest thing to do is just count directly to the line. This is 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 on the other side. So that point is the point 2 and then negative 5. So remember, you count from your 0. So down 1, 2, 3, 4, 5. All right. Again, if you have questions, go ahead and write those down. And let's look at our last one. All right. So we've got our original coordinates here with this one. And what we're going to do is going to start by graphing our original figure. So we have, I'm going to change colors here. We're going to put F is at the point 0, 3. All right, G is at the point 2, 4. H is at the point 4, 2. And J is at the point negative 2, 0. Oop, negative 2, 0 here. That is J. So there is my figure. Okay? So then from here, we're going to reflect it over the x-axis. That was really big. Okay? This is already on the x-axis, so J prime is going to stay the same. So J prime is still going to be at negative 2, 0. Okay? Then we're going to reflect F. F is 3 above, so we're going to go 3 below. So F prime is going to be at negative 3, 0. Oops, sorry, 0, negative 3, backwards. All right, G is at 2, 4. So it's 4 above, so we're going to go 4 below. So G prime is going to be at 2, negative 4. And then H prime, if H is 2 above, we're going to go 2 below. H prime is going to be at 4, negative 2. And again, remember our rule for reflections over the x-axis is x, negative y. So this is why we know right here that all we're doing is negating all of these y values here. All right. Now, we're going to do the same thing, but we're going to reflect it over the y-axis, which my rule for y-axis is negative x, y. So we're going to start by regraphing our original figure. So J was here. F is up here. G is here. And H is here. All right. So then we're going to graph over the y-axis. So we're going to negate our x values. So if I look at J prime, J comes here. Over the y-axis, it's going to flip to this side. So over here will be j prime. So j prime, remember, we're just negating the x values with this one. So instead of changing the y's, we're going to change the x's here. Okay? So j prime is going to become 2, 0. F prime is on the y-axis, so it is not going to move. It's still going to be 0, 3. All right, H prime is here. It's 4 from the y-axis, so we're going to go 4 on the other side at the same height, so it becomes negative 4. I was going to write 2 here, so negative 4, 2. And then G prime is 2 from the y-axis, so we're going to go 2 on the other side, and that becomes negative 2, 4. So again, all you're doing is just switching the value of your x from positive to negative or from negative to positive. So F prime stays, and there we go. All right, so if you have any questions on that, please make sure that you write them down and let us know, and we will see you in class.